Okay, good morning, students. Today we will start fourth unit. The fourth unit, first topic, Classius Theorem and a definition of entropy. Here, Classius Inequality is a common relation everywhere we are using, proposed by R.J.E. Classius in 1822 to 1888. His tenure of research is cyclic process summation of all heat interactions divided by boundary temperature always less than or equal to 0. So cyclic integral of dou q by t always less than or equal to 0. This is the inequality. It is applicable only cyclic operation. So to prove this relation, generally, first we are selecting one unknown process, reversible process. I2F, you see, this is the unknown reversible process. I don't know which type of reversible process. But now I want to determine how much heat transfer is takes place by this process. How I can determine? I can substitute this unknown process by known process. The noun process I am selecting B2F adiabatic process, I2A parallelly I2A one more adiabatic process, and A2B isothermal process. So IF is substituted by IABF in zigzag way. IABF I know one is adiabatic process, second one is isothermal process, next one is adiabatic process. But what is the condition? Some condition is required. On PV diagram, the area under IF curve, the area under IABF curve must be equal. If the area under IF curve and IABF curve is equal, means same work output. The work output under PV diagram will get the maximum work output. So the work output of the process is equal. If you substitute, then QIF equal to QIABF, QIA adiabatic process heat transfer is 0, QAB isothermal process, and QBF one more adiabatic process. So QIF unknown process, just QAB isothermal known process. Heat transfer in unknown process of IF is equal to heat transfer of known process of isothermal. So like this unknown process, or we can substitute by known zigzag process, we can solve the problems. We can determine the heat interaction. Like that, one more unknown cycle. It's a combination of one circle. It's an unknown combination of process. I don't know. It's a cycle. Then what I am doing, I am dividing this cycle by adiabatic lines and intersecting by isothermal lines. So this unknown cycle I am divided by known Carnot cycle. Carnot cycle contains isothermal heat addition, adiabatic expansion, isothermal heat rejection, adiabatic compression. So what is the condition? Area must be equal. In this condition, the unknown cycle is substituted by the known process. We can achieve the. Then in Carnot cycle we know heat transfer is directly proportional to temperature. Then automatically dou Q1 directly proportional to T1, dou Q2 directly proportional to T2. Then dou Q1 by T1 equal to dou Q2 by T2. Like that you can add. For n number of process you are adding in cyclic operation, dou q by t equal to 0, because 1 is positive. Dou q1 by t1 equal to dou q2 by t2. Then the summation must be 0. Like that. In cyclic operation, dou q by t equal to 0. In reversible process, the reversible cyclic operation, summation of all heat transfer divided by the boundary temperature always 0 in reversible. Irreversible less than 0. Next. Then after the Classius is realized in I think 1865, he is not introduced inequality, he introduced one new property. By using that new property, we can determine the unavailable energy. Then total energy, if we know the unavailable energy, we can calculate the availability. Because if we have 10,000 kilojoules of energy, but how much is ready to convertible we want to calculate. For that, entropy property is the major driving force. So in 1865 he realized it is not inequality, it is a new property, is entropy, total entropy, dou q by T for reversible process. Units are kilojoules per Kelvin. But it is an extensive property. We required intensive property, so kilojoules per kg Kelvin. Then you will get the intensive property. So up to now we are not defined entropy. Just one property introduced, we named as entropy. What is entropy? One tank contains molecules, air molecules, something. They are freely movable. So automatically, if you are supplying some heat, further random movement will take place. The degree of disorderness existed in the system is known as entropy. But absolute value we can't. Total disorderness, how much we don't know. By our process, how much of degree of disorderness is attained, we can measure. That is called entropy. By different process. If I moved constant pressure process, how much degree of disorderness of molecules is occurred? Constant temperature process or constant volume process or adiabatic process, whatever. By different process, if I am moving, how much degree of disorderness we are achieving, that is called entropy. Next, entropy is a property or not. Suppose we considered for state 1 to state 2, I moved by path A and I returned to path B. And one more time I returned by path C. Then path A, dou q by T in 1A 2B. In this cycle, dou q by t at A plus dou q by t at B is 0. Then dou q by t at A equal to minus dou q by t at B. Same from 1A to C1. Here also same. The magnitude is not changing. The direction only changing. So the property is independent of process. So entropy is a point function, not a path function. It's a property. That's why in steam tables, specific volume, enthalpy, entropy with respect to pressure or with respect to temperature we are getting from the steam tube. Next, this inequality ratios, we developed inequality ratios. Dou q by t equal to 0, reversible process. Dou q by t less than 0, irreversible process. But it is a possible process, it is an actual process. But dou q by t, cyclic integral of dou q by t greater than 0, then it is an impossible process. Coming to ds equal dou q by t in reversible process. Next, ds greater than dou q by t, then irreversible process. ds less than dou q by t, it is a impossible process. These are the relations we can expect in computation exams. Cyclic integral of dou q by t less than or equal to 0 or ds always greater than or equal to dou q by t. Next class we will continue further. Thank you.